All right, today we're going to look at adding and subtracting polynomials. So there are rules to write down, so let's go ahead and get started with those rules. So you're going to write each polynomial in parentheses. And a couple of things to remember: that if you're looking for the sum, you're going to be adding. If you're looking for the difference, you're going to subtract. Now, if you're going to be subtracting, you're going to have to apply the distributive property. That's really the only difference between what the next process is combine like terms and write in standard form. So remember, standard form is going to be like x squared plus x plus 2. So you want the largest exponent first and the constant to be last. So here we're adding. Both terms are in parentheses already. Because we're adding, it doesn't change the sign, but what I do want to do is kind of color code things. So in this case, this term and this term are like terms. This one and this one are like terms, while the 12 is going to stay as it is. So when I go to combine these, I have negative 3x squared plus 5x squared will give us a positive, let's see, positive x squared. Then 5x plus 3x is a positive 8x, and then minus 12. This is as simplified as we can get, and it is in standard form. So typically, I'd start combining terms with the largest exponent first, and then work my way to the smallest, or to that constant. All right, now again, we're combining, we're gonna be adding, so we can set up like giant addition, but the tricky part here is that they're not lined up. So let's see, this term is with this term. The x to the third power is by itself, and then we have these terms that are alike, and last but not least, these guys. So I'm trying my best to color code this for y'all. So starting with the largest exponent, that would be a negative 12x cubed. Then I'm going to go to the x squared. So that's a positive 14 and a positive 10. So that would be plus 24x squared. Then I have the negative 14 and a negative 24, which would give us a negative 38x. And last but not least, 44 plus 15 will give us 59. That one's kind of tricky because it has a lot of terms. So this one actually ended up with 4 terms, and it is a quadratic with 4 terms. So a polynomial. All right, now this is where it gets a little tricky when we have to do some subtraction. So we're going to take this value and we're going to do some distribution in order to create subtraction. So here we have negative 4m squared minus m plus 9 minus 8m squared minus 2m plus 24. So what I did here was I multiplied everything in that second term, or that second expression, times negative 2. Now I can start to color code. So I have negative 4m, negative 8m squared. I have negative just m, negative 2m, and then these two guys. So let's start with our largest terms first. Negative 4m squared and negative 8m together gives us negative 12m squared. Negative m and negative 2m gives us a negative 3m. And last but not least, 24 plus 9 will give us 33. So that this is as simplified as we can get that. Last but not least, one more subtraction. So I'm going to have to set this up and make this a negative sign there. So when I rewrite this, that first one isn't going to change. All that's happening with the second one is all of those terms are going to change sign. So now I have negative 3p squared, positive 2p cubed, minus p plus 12. So now I can go to my colors and color code. So I see here, those two are there. P squared is only one term there, so then we have this, and last but not least, those two. So let's see what we got here. Starting with my largest exponent, I have a negative 2p and a positive 2p. So those actually end up canceling out. Then I have negative 3p squared by itself. Negative 4p and a negative p will give us a negative 5p. And then 12 and 7 will give us positive 19. So this is what we need.